We've got 4 different colour counters in a bag and one's taken at random. We're given the probability for blue or yellow, and we know that all 4 of these probabilities, because they are mutually exclusive events, it can't be red and white, it can just be one or the other, and because they're exhaustive, there's no other colours in there, we know these are all going to add up to 1. So first thing we need to do is add up the probabilities of blue and yellow. And so the probabilities we've got left, red and white, must add up to 0.3 because we take away that 0.7 from 1. Now, we're told the probability that red is taken is twice the probability that the counter is white. So this is going to be 2 times the probability of this. So we've got to split 0.3 is equal to those 3x, and hopefully you can see nice and easily that that means the probability of white will be 0.1, the probability of red will be 0.2. There's 18 blue counters in the bag, so the number of blue counters is equal to the probability of blue multiplied by the total amount in the bag. So we can get the total amount from doing 18 divided by 0.45, which is 40. Using this, the number of red counters, we've seen the probability is 0.2, times that by 40 will give us 8 red counters. Here we've only got red or blue counters in a bag. One's taken at random and the probability it's red is 0.65. To put back into the bag, and another one is taken out and put back in. Now, sometimes with questions they do have parts that are just completely irrelevant. This is just not needed at all. In fact, ignores this. We just need to know what the probability of red is. So there's 78 counters in the bag, and we need to find out how many blue ones. So as we saw with the last question, the 78 red counters, we get that from the probability of it being red, multiplying it by the total amount in the bag. And so dividing both sides by 0.65 here, that gives us the total number of counters in the bag is 78 divided by 0.65, which is 120. Now it's only red and blue counters in the bag, so we just need to do 120 in total, take away the 78 red to give us 42 blue counters. Question 9, we've just got red and blue marbles. One's taken at random and the probability it's red is 1/5. This is put back in the bag, 5 more red marbles are added, and then we've got a new probability here, which we'll come back to in a moment. So we know the probability it's red at the beginning is 1/5. Now it could be there's 1 red marble out of 5 in total, so 4 blue, or it could be 2 red out of 10 in total, or 3 red out of 15 in total, we don't know. But a useful way to write this here is if we do x over 5x, and looking back we can see where that came from, this is going to help us solve the problem. So at the start, the probability of choosing red was x over 5x. Okay, that's equivalent to 1/5. Now, 5 more red marbles are added, so the number of red marbles on top here, we add 5 to it, and the total number of marbles, we add 5 to that as well, and we're told the probability is now 1/3. So these are equal to each other. So if we multiply both sides by 3, both sides by 5x plus 5, then we can go on to solve the equation. Okay, so X, remember we had up here, was the number of red marbles at the start. And the question is asking how many were originally in the bag. So 5 red marbles. And remember from our fraction here at the start, for every 1 red marble out of a total of 5, there must have been 4 blue marbles. So that is 20 blue marbles in total. And let's just check that the numbers here we've put in make sense. So if it was 5 red out of 5 red and 20 blue, so 25 in total, that's equivalent to a fifth, which we had here at the start, so that's okay. Now we add 5 more red marbles, so that would give us 10 red marbles in total, and with the extra 5, that's 10 out of 30, and we can see that's equivalent to a third, the fraction we've got here, so we can check that that is correct.